today we're going to talk about plane mirrors, and then next class we'll finish the other two. So we're going to describe image properties of plane mirrors and give examples of uses of plane mirrors. Anybody know what a plane mirror is? Okay, let's mute our mics, everybody. All mics should be muted. All right, what does the word plane mean when it's spelled like that? P-L-A-N-E. Have you seen that word before? Awesome, Antonio. Flat, okay? So plane means flat. All right? When we want to see an object, we know that light has to bounce off an object and enter our eye. In turn, our eye processes what we see and forms an image with the help of our brain. But how do we see ourselves? Well, if we are the object, then yes, we need a mirror to see ourselves. So the light must bounce off a reflective surface, and in many cases, our everyday mirrors are flat mirrors or plane mirrors. So it's not plane as in the opposite of fancy, okay? Plane within A-N-E is a math word, and it means flat, okay? A couple more people joining. All right. So when light bounces off a smooth object, some of the light rays go off in random directions, and some bounce off the mirror, which is what we want. Those that bounce off of the mirror, they enter our eye, and they form an image. Now, the image, before we get there, let me do a quick review of reflection. Do you remember the law of reflection? What does the law of reflection say? Okay, Mike, muted. What does 9 represent? Yes, this is the normal. This here, this is the mirror, okay? Why is this one? Just get this pencil under control. All right, this is the mirror, the shaded surface. That's the mirror. And this is a ray of light that's striking the mirror. You're close, not accident, but incident. Very good. There we go. It's coming back. It's coming back. This is our incident ray. This is the one that first hits the mirror. And then after it hits the mirror, it bounces back. So this ray is called the what? Right, the reflected ray. Okay. Then, no, not the normal. The normal is the straight line, the dotted line that's going up from the mirror. So that line there is the normal. Okay? Then we define two angles. The first one is the angle of incidence. And where is that located? Where is the angle of incidence located? Very good. Between the normal and the incident ray. This is our angle of incidence. So where's our angle of reflection? Where's our angle of reflection? Exactly. And what do we know about these two angles? Angle of incidence and angle of reflection. What can we say about them? Very good. They are equal. So, based off of that, and what we know about, based off of that and what we know about angles at a point, angles at a point all add up to what? Or angles on a straight line? 180. Exactly. So if this represents the halfway mark, where the normal is, would be the halfway mark, okay? Because if I'm measuring an angle, I'm starting from one end of the line, going all the way to the other end. So this would be the full angle, and that angle is 180 degrees. So half of that is going to be what? 90, which we can easily recognize as a right angle. Okay, so anytime you have a vertical and a horizontal line, so intersecting, so the mirror and the normal make a 90-degree angle. Now, if again, we cut that 90-degree angle into two parts, and we know that this part here is 25 degrees, then what's this part? What's this angle? Awesome. 90 minus 25 is going to give us 65. What have we just found? Which angle have we just found? Right here. in purple. Exactly, we found the angle of incidence. We're asked for the angle of reflection, but we know that that is equal to the angle of incidence. So therefore, our answer must be what? $65, B. All right. Answer B. All right. Let's keep going. So, plane mirrors, when we have light bouncing off a plane mirror, the laws of reflection apply here as well. Okay? So what happens is, if you look in a mirror, when you look at your reflection in the mirror, it seems as if there's another, for lack of a better word, an object that is on the other side of the mirror. We call those types of images that are formed by plane mirrors virtual images because they're not cast on a screen. Okay? What the rays actually do, so we have a person and they're looking at this chess piece through a plane mirror. The light rays strike the mirror and then they bounce off and enter the person's eye. But if we trace back the path of those reflected rays, we're going to find that they all meet up at the same place behind the mirror. Okay? Now, there's no light actually passing through there, and there's no object behind there. It's a virtual image. It's the point where the light rays would meet up if there was an object at that exact distance. That would give us the same picture as the object in front of the mirror. Okay, so plane mirrors form virtual images that can't be formed on a screen. Now, plane mirrors have some other properties that we need to remember as well. So besides the image being virtual, and I know that might be a kind of difficult concept for you to internalize, but all it means is when we talk about an image, we're just talking about the place where the light meets up, okay? So other plane image properties are that the object in front of the mirror is going to be at the same distance as the image is behind the mirror. Also, when you look in the mirror, you see that the top of your head is the same place in your reflection as it is in real life. That means your image is upright. It's not upside down. You're also the same size as your reflection. So you're not magnified or diminished. You're the same size, you're upright, and you are the same distance in front of the mirror as you are behind. So if you walk closer to the mirror, then obviously the distance between you and your image is going to be smaller. let's look at this in a question so this makes more sense. All right, so we have a diagram showing the position of the eye of a person looking at the reflection of a toy rabbit in a plane mirror. So I'm going to circle the one that's our objects, and the others are the images. Which image is going to be formed for this object? So what I've circled is the object, and we're looking at different positions where the image can be formed. So based on what I just said about object and image distance, which one of these, A, B, C, or D, is going to be the image of the object? Awesome. Exactly. Okay? It's going to be A. Okay? First thing we said about plane mirrors is that they produce virtual images or images behind the mirror. Okay? So we know that D and C are out. Okay? Because those images are in front of the mirror. Just get control of this. Get these out of my screen. All right, so those are out because they're in front, okay? And then our image distance has to be the same as our object distance. So that disqualifies B, okay? It has to be along the same line of sight, okay? So correct answer, only correct answer is A. All right, let's try one that's a little bit harder, but I know you can figure it out. All right, so we have a diagram that shows the arrangement used by an optician to test a patient's eyes using a chart and a mirror. So the chart is placed behind the patient's head. This is the chart, okay? This is going to be considered our object, okay? The chart is the object. And it's placed 1 meter from her eyes, and she views the chart in the mirror 2 meters in front of her eyes. So this is our mirror. What is the distance from the patient's eyes to the image of the chart produced by the mirror? I'm going to give you a minute to think about it. But I'm going to give you some steps, okay? So the first thing you need to answer these questions. Where is the image of the chart? That's your hint. First thing you need to do is find the image of the chart. And remember, object distance is equal to image distance from the mirror. Okay. Is the image going to be in front or behind the mirror? Good. How far behind? How many meters behind the mirror? All right. How far is the chart from the mirror, first of all? That is our object distance. How far is the chart in front of the mirror? That gives you your object distance. So if the object distance is 3 meters, then what is the image distance? What did I just circle? This is my chart. This is my mirror. The distance from my chart to my mirror is what? 1 plus 2, which is 3 meters. So my object distance, OD, is equal to 3 meters. So if my object distance is 3 meters, and my object distance must be equal to my image distance, what is my image distance? Why are we adding? Equal. Object distance is 3 meters, so image distance is also 3 meters. Just like angle of incidence is equal to angle of reflection, if the angle of incidence is 65, then the angle of reflection is also 65. If the object distance is 3 meters, then the image distance is 3 meters. So that means that the image is 3 meters behind the mirror because the object is 3 meters in front of the mirror. This is my my image. And it's 3 meters behind. Does everybody see that? Remember, the chart is the object, not the woman's head. Okay? So, if the image is 3 meters behind the mirror, what is the distance from the image to the woman's eyes? Very good. Very good. All right, so it's 3 plus 2, which gives us 5 meters. Okay? So the number 9, how it's written in this picture, okay? I'll give you a minute. Get the paper, get a pen, draw it on the paper just like that. So when you hold it up flat again, and you look at your screen, it looks like that. When you've done it, just type done in the chat box for me. Actually, you've drawn it. All right, great. And look at the reflection and draw it on the other side of the paper. Draw the image, how the image looks on top of your drawing on the paper. Go and take it up to the mirror and look. And make sure you hold it flat. Hold it on the screen. And you hold it up. All right. Everybody had a chance to do it? I'm going to tell you what you should have seen. You did it correctly. All right. So if you said D, then you're absolutely correct. The reflection, the image that you're going to see in the mirror is going to look like D, okay? And let's talk about why. So it's for the same reason that we were able to figure out where the image was in the last question. Remember, object distance is equal to image distance. So if you look at the number 9 as a bunch of points where light is reflecting off of, every point, every light ray that bounces off of that object lines up exactly on the other side as the image. One second. All right. So if you remember from math when you did reflection of triangles, squares, and you drew your mirror line, you're doing the exact same thing here. So if I take this point and I line it up on the other side, it's going to end up right about there. And if I do that, oh, let's take that one out. We don't want that there. That one. All right, line up right about there. If I take this point and I transfer it over, it's going to end up right about here. If I take this point and I transfer it over, it's going to end up right about there. And if I do that for every little point on this shape, eventually I'm going to be able to trace it back, and I'm going to get this image right here. Okay? All right? So if you didn't get it the first time, make sure that you use the image properly and try it again. Try it with other shapes and see if you can predict what the image is going to look like. Draw a B, draw the letter D, and see what it's going to look like. Okay? I have another interesting fact to show you. Have you ever noticed that on an ambulance that the word ambulance is flipped horizontally? Anybody ever see an ambulance when it's parked? The word is actually written backwards. And the reason for that is because of what you just observed. Images in plane mirrors are laterally, which means horizontal, inverted. So they're left, right, reversed. And so when you look in your rear view mirror, which is a plane mirror, the middle one, okay, the middle one in the car in the front, when you look in that, the word ambulance looks like it's supposed to. It reads from left to right, but that's because the designers of the bus, the ambulance bus, they flip the word so that when the mirror flips it, it ends up back in the same orientation that we want to be able to read it. Because when the ambulance is riding on the road, they want the people that are in front of them, when they look back, to be able to see that this says ambulance and, hey, get out of the way, okay? They don't want you, they're struggling in your rearview mirror to say, oh, what does that say? Is that an ambulance, okay? So leave no room for error. So another property of plane mirrors, besides the fact that they make virtual images, that the images are the same size, that the images are upright and at the same distance behind the mirror as the object is in front, they are also laterally inverted or left, right, reversed. Okay? So those are a lot of things to remember about plane mirrors. I'm going to give you a mnemonic in a little bit to help you remember them. Can you answer this question for me? On the front of an ambulance, the word is often written backwards in large letters, as shown. Why is the word written in this way? And guess what? There'll be a PowerPoint. It's going to be uploaded in a couple of minutes. You can head over to Edmodo as soon as I'm done. So is it written in this way to make it show up more clearly, to make other drivers think about what it says, so that it reads correctly when the ambulance is reversing, or so that it reads correctly when seen in a car's rearview mirror? Awesome. A pluses all around. The answer is definitely D, okay? So that it reads correctly when seen in a car's rearview mirror. Good job. All right. So characteristics of plane mirrors. So there are a lot we have to remember. So here's how we can make remembering them a little bit easier. I want you to remember the sentence. Proper lane is very uptight, so don't start shouting. I want you to say it to yourself 5 times over and over. Okay? You don't have to turn on your mic to do this. I just want you to do it. Okay? So, proper lane is very uptight, so don't start shouting. Proper lane is very uptight, so don't start shouting. Proper lane is very uptight, so don't start shouting. Proper lane is very uptight, so don't start shouting. Proper lane is very uptight, so don't start shouting. Now that you have that stuck in your head, what does it mean? So of course the P is for plane mirrors. Lane is L-I for laterally inverted. V, very, for virtual. U, uptight for upright. So don't, same distance, okay? And start shouting, same size, okay? All of those properties are very important, and you're going to have to remember them. So use this mnemonic to help you to keep them all locked in your memory, okay? All right. Question. Which of these is not true of the image formed in a plane mirror? Which one does not belong? A, B, C, or D? Awesome. Awesome. You're very smart. I did not even mention the word real once. You were able to use your process of elimination and know that the others, so it must be B. Okay? You're absolutely correct. Okay? A real image is the opposite of a virtual image. Okay? So a real image is an image that you can form on the screen, like from a projector or from a camera. Okay? And all the others we know are true of plane mirror images. They are laterally inverted, they are the same size, and they are the same distance behind the mirror as the object. Okay? Great job. Another question. The letter P is placed a distance 4 centimeters in front of a plane mirror. Which row in the table gives the properties of the image formed? This one is a little bit trickier, but I know you can get it right. I see some answers rolling in. What are the rest of you thinking? All right. So if you said B, you're absolutely correct. A pluses all around. Everybody got B. Very good job. Okay? Now, with these types of questions, so you're going to see these a lot on paper one, where you have two tables and you have to essentially, you have to know that both answers are correct before you can choose your answer. It's helpful to go through one column at a time and put checks and X's, okay? So for a type of image, we know that for plane mirrors, the type of image is virtual, not real. So I'm going to put a check next to all the virtuals and an X next to all the reals, okay? If you're a person like me, you know, I can't juggle too many things in my brain at once. So I like to do things systematically, okay? So then I will go to the orientation of the image, and I will deal with that concept. And I know that plane mirror images are not inverted. Inverted means upside down, okay? So that's not right. They are upright. So that's not right. That's not right. Laterally inverted means left, right, reverse. That is true of plane mirror images. So what I'm going to do now is look back and see which row has two check marks, because if even one is wrong, then the whole thing is wrong. So I can clearly see my answer is B. Okay? So when it comes to questions like these, it's better to take one column at a time than to guess. Okay? Because you're dealing with two things, and you might only look at one and then get the problem wrong because you didn't focus on the other column. They both have to be right. Okay? Good job. All right. So guys, that brings us to the end of our lesson. And your assignment, until I see you on Wednesday, you can start this, is this worksheet, and it's uploaded already. Should be uploaded already. Okay? You can answer these questions on paper, and or you can do it in a Word document. Okay? And then you're going to upload it to Edmodo. One thing that I need to tell you is to ignore, and I put this in your instructions on Edmodo, but I'm going to say it here just in case anybody forgets. I want you to ignore this question, okay? Because that's not covered in this lesson. So number 5, ignore, okay? So I want you to do number 1, number 2, number 3, number 4, and number 6, I'm going to give you as a bonus, okay? That's a bit of a challenge, but let's see how many of you are going to get it. So number 6 is a bonus, okay? Are there any? Yes, the PowerPoint is uploaded. I have it scheduled to go up at 11, so it should go up very, very shortly, okay? Does anybody have any questions? All right, just one word of announcement. When we meet again on Wednesday, I'm going to meet with both classes again at the same time, okay? So you can actually let me know, do you prefer the 10 o'clock slot or o'clock slot because we're only going to have one 10th grade class from now on because the attendance was a little scattered for both classes. So I'm just going to combine you, okay? So you want to do like 10:30? I think that could be fair, okay? So 10:30, is everybody okay with that? 10:30 to 11:30. All right, great. So we'll meet in the middle, okay? And again, if anybody has any issues, I'm always going to record. So you can get that from me. I had asked for someone to volunteer to put together a list of emails so I can facilitate the distribution of the videos a bit better. If somebody would be so kind, 1 or 2 people, to do that for your grade level, that would help me out a lot with getting you your videos on time, okay? So if you want to volunteer, please send me a message so I can send you the class roster to help you out with keeping track of all the names and knowing who you need to get email addresses from. All right? If there are no other questions, okay, Shasta started? Okay, great. All right, so can everybody send your email address to Shasta so she can combine them? Okay, and send them all to me. So once I finish a video, I will just send it to everyone on the email list. All right? If there are no questions, then you are free to sign off. You did a great job today. Pass the message on to anybody who was there. Let them know what's going on, okay? All right, goodbye.